Hello, Pathways class. I wanted to start off by reminding you of our live classes. And let's see if I can find that. There it is. We're going to have some live meetings Wednesdays. And I know this is early for you, so let's see how many people show up. But ours is going to be between 9:30 and 9:50. And some of you are like, wait a minute, I went to bed at 3 o'clock. Well, remember, these, like all the classes, these are optional. If you're having any questions about what's going on, you want to come to these live meetups, this would be a great place to ask those questions. If you know what's going on and you're completely comfortable with what's happening, then maybe you don't need and you don't want to see other people, your classmates or me, well, then the live meetups won't be for you. But they are an option. They're going to be Wednesdays from 9:30 to 9:50. Okay. Okay. Well, we're finally ready to get into some of the actual content of our time together here. What we're going to do is we're going to go back. We're going to talk about experimenting a little bit, because what we're going to do is start off with an experiment that will lead us into our first topic of aerodynamics, which you know a little bit about. Aerodynamics sounds really fancy, but it's really not. So the study of things flying. You've all thrown something through the air, whether it be a ball or a rock or a stick or something, you've thrown it. Well, you've done aerodynamics. Maybe you've been in an airplane, you've seen an airplane. That is aerodynamics as well. But before we do that, experiment aerodynamics, we have to remember what an experiment is. And what we've gone back to here is I have an experiment. I have 3 plants here. Well, I don't have 3 plants. Someone did. This is just a picture of 3 plants. And this is a typical example for what an experiment is. Because what we're trying to do as an experiment is do something scientifically. The definition of science is the way you do something and the knowledge you get. And the way you do something is important. So if I were to have these 3 different pots here, and I was trying to figure out what would make the plants grow, I gave this one a quarter of a cup of water every other day. I gave this one a quarter of a cup of water every day. I gave this one a half a cup of water every 4 days. I gave this one some fertilizer, this one no fertilizer, this one half the fertilizer I gave that one. If the plants if I were to see a difference in them growing, I wouldn't know what made the difference. Did this one grow more, like it seems to be here? Did it grow more because of the different amount of fertilizer? Did it grow more because of the different amount of watering? Because I change more than one thing at a time, I don't really know what was the deciding factor. Now, they started off with a pretty good experiment. They kept some things the same. It looks like the same type of plant, okay? They have the same type of pot. It looks like relatively the same amount of dirt, but we don't know if they controlled everything, and that's the key word here, is controlled. What you're trying to do is create a controlled experiment, right? Controlling an experiment means you only change one thing, or you try to. And sometimes you do an experiment the best you can, and then when you look at it, you think, well, I really didn't control just one thing, so I really don't know if the experiment was valid. All right, so let's go to our website, and if you forget how to get to the website, there's 2 ways you can get to it. I'll put a link in our Google Classroom, but if you just want to do a quick way, the way to get to our website is go to your favorite search engine. Mine happens to be Google because it's default. And if you put in here, click on the waterfall. A very unusual statement to put into Google. Click, probably not the most unusual one that's ever been put in there. Click on the waterfall. My website will be the first one that pops up. This is right there. Then you actually have to click on the waterfall. It's a super secret entrance in, and you'll come to our website. Right? And you are Pathways class. You'll see a whole bunch of stuff here that doesn't pertain to you, but this does. I also put these recordings here in the 9th grade distance learning. I put a copy of them there as well. So you're going to go to Pathways. And right now we're talking about controlled experiments. And a controlled experiment is an experiment in which all the variables except for one remain the same. So if we did an experiment here, all right, everything should be the same except for one variable. one thing that changes. So if this is a good controlled experiment, these are all the same pots. These are all the same plants. There's the same type of dirt from the same bag or same spot, the same amount. They would be watered with the same amount if they're talking about watering. They'd be given the same access to sunlight. Okay, they'd be in the same temperature. You can't have one in one room and one in the other. All right, this experiment is actually microwaved water. Does it kill plants? So what the experiment is, they're keeping everything the same, except this plant here. I believe it was this one. I'm not really sure. I believe it was this one. Oh, what does it say? Boiled. Nope, it was this one over here. They gave water, okay, the same amount of water, but this water here, the only difference was they put that same amount of water in the microwave, boiled it, and then watered the plant with it. Everything else is, they tried to control the same. So the only difference is this has boiled water that was boiled in the microwave, and then everything else is the same. If there's a difference, you may look at that experiment and say, if these all died off, you say, look at everything else was the same, except this one plant right here, it got boiled water. So I'm going to say boiling the water first does something to kill plants. Then maybe you'd repeat the experiment a few times and see if it repeats. A good controlled experiment should be repeatable by yourself or anyone else. They could take all your notes, read them, and then repeat the experiment. And they should look at it and go, okay, I know what I need to do. I keep everything the same. The only thing I'm going to do is boil the water before I use it to water these plants here. All right. So a controlled experiment, an experiment in which all the variables except for one remain the same. So what is a variable? Well, let's try and find that one. There we go. A variables. Any factor that can change during an experiment. So a variable is anything that changes. You didn't expect it, or you did expect it. You boiled the water first. That's a variable. There are two types of variables. Okay? Two types of variables. Okay? The manipulated variable. That is what you are manipulating. A variable that is changed in the experiment. The manipulated variable. It's sometimes called the independent variable. You may have heard that term. Independent variable and manipulated variable are the same thing. In this situation, what is the manipulated variable? What is the experimenter changing? They're not changing the type of pot. They're not changing the amount of soil. Probably not the amount of sunlight. The manipulated variable is the boiled water that they're using. These are not getting that variable. This one is. So the manipulated or independent variable is what you as the experimenter change in the experiment. And in this case, it's the boiling of the water. Okay. The responding variable is the factor that changes as a result. So you might think if I manipulate and change one thing, in this case, boiling the water that you water with, I think the plant will grow more if I boil the water. I think the responding variable will be if I boil the water, the response, the responding variable, the change, the other change is going to kill the plant. I think that if I manipulate and I boil the water first, the leaves will be more green. The leaves being more green is the responding variable. And you can write that out. You've heard of this before in a hypothesis. That's that if-then statement. And it says, if I change this, then this will probably happen. This is what's going to happen. All right? If then. If I boil the water, if the water is boiled, then the plant will have greener leaves. All right. So let's see a hypothesis here for this experiment here. A hypothesis for this experiment would look like this. If the water is boiled if the water is boiled and used for watering, then the plant will have greener leaves. Maybe you think there's something about boiling that water. If I boil it, I'll get out impurities and it'll just be pure water, and that would make it a healthier plant and the leaves will be greener. No. Or you could say, if the water is boiled and used for watering, then the plant will not grow as much. You're thinking, if I boil this water, that's my manipulated variable, that's what I'm changing, the responding variable, the plant will not grow as much. Okay? Or you could say, the plant will die. If I boil this water and take out those impurities, the responding variable, the plant will die. Okay? So, if we were to look at this, the first part of the hypothesis, this is a hypothesis. Okay. This part here, if the water is boiled and used for watering, this is my independent or manipulated variable. Manipulated variable. All right, that's also called the independent variable. This part here, the second half of the hypothesis, here, then the plant will die. This is the responding variable. Responding variable. It's responding to what you manipulated. Okay? This is sometimes called the dependent variable. Dependent variable. And this is sometimes called the independent variable. They mean the same thing. Put that with that. Okay, my independent, I'm going to change this. This is going to be independent of the other stuff. I'm going to manipulate this. The boiling of the water before it's used. If I do that, then I think the responding variable, the other change, will be the plant will die. Or it will depend, the plant dying will depend on the fact that I manipulated that. Okay? All right. Let's go back here. Why can't? There we are. All right, so from this first Quizlet here, the only words you're going to be responsible for are hypothesis, variable. Right now, hypothesis, variable, manipulated variable, and responding variable. That's what we covered today. Tomorrow, we're going to go over experiments a little bit more. We're going to talk about observations and datas, inferences. And we talked about science. Science is what you learn and the way you go about doing it. So this experiment is scientific. They're doing a controlled experiment. They're doing it in a thoughtful way. They're keeping everything the same. Okay? And here's a little bonus. Everything you keep the same is called a constant. The pot is a constant. The amount of sunlight it's getting, they're all kind of grouped together in the same window. The sunlight is a constant. The amount of the temperature, since they're all grouped together, temperature would be a constant. Proximity to the window, how close it is, that's a constant. How often they're watered would have to be a constant. A variable would be that, in this case, this one's getting boiled water and the other two aren't. That's a variable. In fact, it's the manipulated variable. Okay? All right, that's it for today. If you wanted to, keep going to the wrong one. The Quizlet's right here. And if you wanted to get a little sneak peek on the aerodynamic stuff we're doing, it's here on our website. What we're doing with aerodynamics, we're going to talk about how things fly. So, and we're going to do an experiment with flying, which should be fun. All right, everybody. More on experiments tomorrow, and then our live class not live class, but a live meetup on Wednesday, and we'll see who shows up bright and early. All right, everybody. I'll see you in the next one.